Hi, humans of the earth. Hello. Welcome.
Uh, yes, I'm Wayne Sutton, Community Manager at Observable, and welcome to the Data Science for Environmental Research and Advocacy Meetup, and it's welcome to Earth Day as well, 2021.
Yes, we are here on Earth. We made it to April 22nd, 2021. So I think we just need to give ourselves a round of applause for that because it has been a time on this Earth recently. So just want to express how grateful we are to be here with all of you. Hello, I'm Anjana Vakil, developer advocate at Observable, dialing in from San Francisco today, where my lovely co-host Wayne is also across town. Would love to hear where everybody is dialing in from around the Earth today. I think we've got folks from all over the place. I see folks from London, from Boise, Idaho. We got folks dialing in from New Zealand. I love this. So if folks want to share your location with everybody in the chat, please do, so we can see truly what an Earth Day celebration we have today. I am so excited we're doing this. We are going to have a really interesting discussion today from some amazing folks who work on environmental research and environmental data. And of course, being observable, we want to know how can we use our magic powers of data science and data visualization to understand the Earth better and understand how we can advocate for environmental issues better. So I'm really excited to have this conversation happening today. And everybody joining us from, look at this, we've got folks from Toronto, Canada, Charleston, South Carolina. We got folks in Florida, and Utah, Seattle, California, Bay Area, Warsaw, Poland. Hello, Madrid, Spain. We got folks over in Europe. Awesome. And Germany as well. California, Massachusetts. Look at this. Very excellent Earth representation, everybody. Good job. Wonderful job. So lovely to have you all here. So I think we are going to, without further ado, introduce you to a very special person who has been working with us as an Observable ambassador and has gone above and beyond to gather folks today for this conversation around data science for environmental research and advocacy. So please join me in welcoming Aaron. Are you with us, Aaron?
I am.
Hello. Hi, would you like to introduce yourself?
Yeah, no, thanks for having me, and thanks to everybody who's joining the conversation. I'm getting a bit of an echo, so if others are too, maybe let us know in the chat, and otherwise I'm just going to try to power through it, and it's probably an issue on my end. But before I go too much further, it wasn't just me who helped to put this together. Amanda McCarty, who will not be joining us today, did the other half of the work of finding people to join, and we have a lot of great environmental scientists who are going to introduce themselves and their work today. So everybody, I really appreciate your time. We also have other Observable ambassadors who are going to walk us through some of the work that they're doing, and otherwise we're just going to talk about information and how we can use it, how we might want to be using it differently. If you have data sets that you think are interesting and you kind of want us to look at, please point to them in the chat. I see some folks already have. And otherwise, we're going to be exploring more over the coming days the data sets that are being talked about and shared from the National Oceanic and Atmospheric Association, and linking to them a little bit more in the notebook announcement that we used to introduce this. But other than that, this is a celebration of Earth Day. This is why we're having this environmentally themed discussion. I think we all recognize the critical importance of the environment to our futures, to the future of our planet and other generations. And I think that what I'm most excited about is that we're talking about open and public data that we can kind of grab and explore and play with, and on a platform, Observable, that many of us love, and that's what we want to talk to you about. That gives us an opportunity also to consume and to dig into that information, all without having to do anything. Like I don't have to install any software. I can just I have to learn a new language, which can be challenging, but and we'll get to some of that. But I guess that's kind of the point of all of this, is to introduce some folks to Observable, introduce other folks to environmental data, and ideally encourage a meeting of the minds. So thank you again.
Well, and that's the whole point, right? We're all in this together, right? Like what happens to the earth, what happens to our climate and our environment it affects all of us, and not necessarily in ways that we might expect, but we are all on this blue marble together. And so likewise, like we should keep in mind that we can work on these type of data science problems together. And so that's what we're really trying to do with events like this, and with the new features that we're building into the Observable platform to make it even easier to collaborate with people, to share notebooks, to work in private with other people, even if you don't have a team with them, to have multiplayer editing so that you can see each other's work in real time, and pair program in real time, and fork each other's notebooks and extend each other's work, and really like do this work together so that we can understand these issues better together. Because again, we're all in it together. So that's the thing. Yeah. Yeah. So pleased to have you here. And thank you, Aaron, for bringing us together, and Amanda as well, for bringing us all together. Really excited about it.
Thank you. And I think, though, that's going to be enough of me for now. So I'll say thank you, and I'll pleased to welcome the other ambassadors. And I think Christoph is the next one that we'll be having talk. So I'll sit back and enjoy. Thank you.
Awesome. So let's give a few moments here for Christoph to join us. And in the meantime, if folks haven't checked out the notebook for this event, Data Science for Environmental Research and Advocacy, the link is in the chat right there. So you can take a look at some of the folks who are going to be sharing with us today. We have several of the Observable ambassadors. And if you haven't heard of the Observable Ambassadors Program, this is an amazing sort of last year new initiative to get more folks from the community empowered to share the work that they're doing on Observable, because folks are doing some amazing things. So we're going to get to hear some of that today. And you can read more about the Ambassador Program at, I believe, observablehq.com/ambassadors. And I see we have folks already sharing resources with each other. I love this. AutoFlow shares an Observable workshop to celebrate the Open Data Day. I love this. So the video and notebook are available, and it looks like this is also in Espanol. That's very exciting. We have a large and growing Spanish-speaking community on Observable. So really hope folks can connect and work together in their, in their own events like these Open Data Day workshops, and sharing resources. So awesome. Hello, welcome. Hi. How's it going, Christoph?
Thanks for having me today. It's such a pleasure. Thanks.
So pleased to have you here. I'll let you take it away. Perhaps you can give folks a quick intro to yourself and what you've been working on, and we are really excited to hear about it.
Thank you. Yeah, hi, I'm Chris. I'm joining today from Germany. I hope my video and audio quality is somewhat okay, because I'm on a farm, and this is something I want to talk about today together with you, because I'm doing agriculture economics research at the University of Bonn. And yeah, one of the main topics that I'm working on is actually single farm economics, and especially the linkage to policy design. And something we are frequently looking at is, and I think there's also the link into the NOAA work that we are also probably going to hear more about later, is nitrogen and phosphate leaching both to the soil, to the atmosphere, and especially also to the oceans. And recently there's been some new policy redesign, actually this spring in the EU. And especially here in Germany, there's been quite some uprising, because farmers now have to follow really strict rules about their fertilization. And beforehand, these fertilization rules used to be on a very coarse scale, but now they are on a single field level. And that poses some issues to farmers. Yeah, and also to us as researchers, because it's kind of difficult from an economic perspective to foresee, because that's something policymakers frequently ask us as researchers, and probably, you probably know these kind of issues where people will approach you and be, okay, we are interested in regulating these flows of excess nitrogen and phosphorus to the atmosphere. What policy can we do that will likely minimize this exflux, but also will not damage the economics of these farms too much? And one issue we're having, I'm an economist by trade, so the problem is getting into highly spatial data is something that I would need expertise from other people. So today I want to show to you, I'm going to share my screen real quick. I hope you can see the notebook now. Please, or could you just someone confirm in the chat real quick if it works? Okay, thanks. I'm just going over to the notebook. So what we've been looking at together with agronomists and biologists is whether we could model in a very, very simple way the yields of certain different soil quality regions within a farm. And the problem often is if we do this in R or if we do this in Python, it's perfectly doable and it's been done ever since. But often, you probably know this issue that you would have to transfer whole big data sets, and sometimes you just want to have you're having a quick question. You're like, okay, I'm not getting further. I don't see a correlation here, probably because it's not really my type of field. Could somebody help me out? And then it's kind of difficult to get them to see what you're seeing without, when you're sharing the screen, they can change any of the variables. So that's what I love about observables. So what we can see in this notebook that I set up, we were looking at historic crop yields. And we're now trying to see, okay, is there can we make a simple model where we have the crop yields together with some soil indicator and also with the moisture, whether we could use this for yield prediction, because that's very important later on to see for the nitrogen and phosphorus uptake. So what is very nice about the observable platform, I could just, for this notebook, I can create a link and send this to all other researchers that might be interested in this, so that it might help me out. So, they could have a look, select a different crop, for example. And the nice thing about observable is, as it's reactive, kind of, you could think of it like Excel, we can see those changes right away. So there's no need, as if you probably know Jupyter Notebooks or something like that, no need to rerun the whole thing. So we could just change this and do the same thing. So for the crop timelines for the yields, something we frequently discuss. Okay, how are they looking different in different regions across the state? And something that we were intensively working with other researchers together was the regression models that we later on use. So something that I could share this link. Some other researcher would say, well, I see you said now, you modeled the crops yield as a function of, let's say, the soil indicator. Let's try if we took the log out of this. How does it change the results? And you can now, they can just quickly apply this and directly observe the results themselves without me ever sending them any data or something like that. So this was really, really helpful in getting some because that's what we, as the economists, we didn't want to have a very precise model. We wanted to have some more tangible cost model that we could use for some just average policy recommendation, not really for prediction of yields that farmers could use for their planning. And this just really very short. What I'm loving about using the observable platform for research, that it's so flexible and there's so much you can do and quickly share. So I'm also really eager to hear or learn about what you guys use it for. So thanks for having me. And I think I'm going back to Anjana.
Hello, folks. Hi. Hi. Oh, computers, when will we figure them out? Thank you so much, Christoph. That was so exciting to see. And I know we would love to play around with your work, your notebooks here. So please, if you wouldn't mind sharing either that notebook or some of the other notebooks you've been working on in the chat, I think we would all love to play around with these reactive charts ourselves. It's amazing to see this work happening and learn more about this. I'm brand new at these sort of topics, so it's very exciting for me. What do you think, Maya? Welcome. Hi.
Hello, everyone. So my name is Maya Gans, and Christoph, that was amazing. I am now, I've kind of moved. So in a former life, I was a mycologist, and I studied microbial interactions, which also is a lot of data, right, in environmental systems. But now I've transitioned to the clinical trial space, and my kind of home where I learn to code is in R. And as Christoph mentioned, in like Jupyter notebooks or coding in R, in observable, and coding in JavaScript, you get to have leverage reactivity and explore your data, iterating through it quickly. So I kind of landed in this because I started as an R developer, which I became a Shiny developer, which is kind of R's wrapper for HTML, JS, and CSS. And something that I just very briefly wanted to share with everyone, and I'm happy to talk about more in depth, either through Twitter or in collaborations in Observable, is kind of my personal workflow and how I use Observable, which is because I still consider R my home. I like to leverage Observable to create custom data visualizations that I can then create an HTML widget wrapper around, so I can use that data visualization within R. So hopefully my screen share will work here, and you can see this GitHub calendar. I'm gonna flip back. Yes, cool. Okay, so this is a simple-ish visualization. I just wanted to, again, lay out here that and again, this notebook is published, and I could share it in the chat in a second, but what I wanted to contrast here was how I created this. I create these charts, tinker with it, what do I want the text to look like? How do I want a subset, whatever. And then make sure by importing different data sets iteratively that this graphic can be extrapolated to any data set. And then another thing that I'll share in the chat as well is this GitHub repo where I take that visualization and tie it using HTML widgets, tie it with R to the JS so that you can import your data through R if that's where you're comfortable. And then now you have this function called GitHub Calendar, which is essentially rendering this D3 object. So getting those two languages to talk to each other is kind of like where I love to live. And if anyone wants to talk about that further, I'd be happy to do so. So yeah, I've kind of strayed a little bit from my environmental past, but I still think that, leveraging data and using Observable to quickly prototype and then use that in your R workflow is a really just valuable tool.
Amazing. Thank you so much, Maya. This is so cool. Maya is really, I think, the person that I would go to if I had any question about that intersection between R and Observable, or the JavaScript data world and the R data world. Like, Maya is there for it. And it's just been so amazing watching your work and your involvement and in the community and in the ambassadors. Like, you are just so generous with your time and your knowledge, and it's just amazing to see. So thank you so much. And thank you for sharing this. Like, I think as you say, like, this focus on kind of prototyping and then playing around and things like that is so important. And that's what we're hoping also folks can, after this event, if folks are interested in playing around with some of these data sets or playing around with some of the types of visualizations that we're seeing, that's what we want. We want play. So please, meet up with each other, connect, and take a page from Maya's book, or a page from Maya's notebook, I guess would be the better pun, to to enjoy that experimentation and prototyping. Thank you so much for sharing, Maya. Amazing. All right. Well, I believe we now have Karim joining us. Hi.
Hello. Nice to meet you, everyone.
Hi. How's it going?
Pretty good. Pretty good. Delighted to be
Lovely
here.
to have
Thanks
you
for
here.
inviting me.
Thank you for being here with us. And yeah, if you would like to maybe quickly introduce yourself and then share with us, we are all ears.
All right. So my name is Karim Douyeb. I'm one of the co-founders of Jetpack.ai, which is a data science company based in Brussels. I'm here today to talk about a few exploration that I've made in the domain of environmental data. I'm not by any means a specialist in the domain, but I like to explore data visualization concepts. And I thought I could use D3GS. Like a year ago, I started thinking about using 3GS, which is a JavaScript library used to create and display 3D graphics in the browser using WebGL. So I wanted to explore 3GS for data visualization purpose. And to do so, I told myself, okay, I can maybe do this with data about environmental issues. So that's what I've done. And the first thing that I've done is trying to replicate this great example of visuals of earthquakes with exaggerated depth. So what I've done is just basically use Observable to do this. I've learned about how to set up 3GS using other notebooks. I've learned about the few basic concepts and ended up replicating our work using so. What 3GS enabled me to do in this case is enabling me to show all the data. So each of the earthquakes is represented with 1 point. It's one particle, and I full controlled it. And it's super powerful. So it was really great to use Observable to explore this and learn about 3GS. In the same setup, I've tried to come up with a new way to visualize global surface temperature anomalies. So that's what I've done here. I've took the data from NOAA, the National Oceanic and Atmospheric Administration. And the data is basically the one you classically see like this. It's like a decomposition of like points on the Earth's surface for more than a century. And so I've just remapped this data into a sphere, 3D sphere. And then I used elevation to highlight positive anomalies and then to highlight negative anomaly over the year. So I transition from one state to the other. Since we don't see each part of it, I decided to rotate the Earth, transition from year to year to get the spinning view. And then to get the same kind of feeling then with the warning stripe, where you see the evolution of the anomaly going increasingly at the recent decades. I've just reproduced the spinning ball for every year on a scale around the main one, showing that the warming anomalies are increasingly occurrence all across the world. So it's probably not the most effective way to communicate about it, but it's as I said, this is just exploration. There's no best practice about this. And maybe to finish, just one quick other exploration that I've done with environmental data about tornadoes. I wanted to show that the amount of tornadoes were increasing over time. so I've used data in a completely different way, visually compelling way. I'm using like a tornado representation to show data about tornado. So I was lucky enough that the data was fitting the schema, but this is like showing a year of tornadoes. Each arc represents a year. The size of the radius of the arc represents the number of tornadoes during this year, and the size, the length of the arc represents the overall average magnitude of the tornadoes during this year. And then you can see it's increasing every year. So yeah, not a specialist. I don't know if this is making any sense, but it's just a fun way to deal with this kind of data and maybe attract people to get more concerned about it. So that was it. Thanks a lot for this.
I think you have successfully blown all of our minds with these data visualizations, these 3D visualizations of the Earth and this tornado of tornadoes. These are like some really innovative, as Christophe says in the chat, some really innovative ways to present this data. And I think it's just such an amazing example of what, you're saying you're not a specialist, but this is when we have open data and when we have open visualization libraries and other computing tools that folks can learn from each other and put together, like this is what happens. We get amazing work out of it that can really communicate a lot of these issues really well. So thank you so much for sharing this. This is so inspiring.
Thank you.
And we're just so glad you could be with us.
Me too.
Thank you. Well, thank you so much, Karim and Maya and Christophe. All of our amazing ambassadors who are just doing phenomenal work here. I mean, wouldn't you say, Aaron? Like, I'm flabbergasted.
Yeah.
I'm speechless. This is so fantastic to see.
Yeah, I mean, I don't even know what to say, because everybody is, I feel, light years beyond me. But this is also what I'm super excited about, right? Like, next, we're going to be hearing from people who are generating these data sets, and it's going to be interesting to think about the ways that we can really dig into explore. And once somebody like Karim does a really innovative visualization like that, and you've got a kind of a similar or comparable data set, you can just steal it, basically, because he shared it with us all, and we can just plug in a different data source and then have a different rendering of that will maybe give us a similar insight, help us to look across different data sets. Maya's work with R is helping to create a different type of expression into these end result visualizations without having to move people out of a process, a tool, and a utility that is familiar and comfortable, which I think is super important work. And then Christophe, it's just like the economic modeling blows my mind. So I'm there again, fascinated and appreciative. Yeah, thank you. It is collaboration, Michael. I'm using, I guess, my words, but yeah. So like we can dig into and read these notebooks and think about the lessons that people are opening up and sharing with us about how we can explore, and then render out information in ways that are kind of easier for people to consume and understand. So on that note, I'd like to now invite some more of this discussion on these data sets that we can think about together. And again, I'm sorry, Amanda's not here to introduce folks, and I'm not necessarily going to do very good justice to anyone. And we didn't introduce this, but we're going to kind of throw you into the conversation. I've spoken, or I've interacted a little bit with a few of you before, and I'm not sure if Rebecca is on the line. We have Tom, Gabe, Jeff, and Benjamin who will be speaking. Louis has cut his hand. I don't know if I mentioned that's the reason why he's not there. Is this Louis? I don't know people's faces. Oh, it's Tom.
I think we have Tom with us. Hi.
So,
hello.
Without further ado, I'll turn it over to all of you. But thank you all for your time and letting us listen and learn from you.
We're so glad to have you here. Thank you for joining us.
Thanks. And you guys can hear me?
Yes.
Cool. Hi, everybody. Cool. Cool. I'm Tom DiLiberto. I'm a climate scientist at NOAA, because it's way shorter than saying the National Oceanic and Atmospheric Administration, at their climate program office. And specifically what I do is I work at the website climate.gov as their staff climate scientist, as well as I'm the social media manager for all of the NOAA climate handles. So we do a lot of work with we do some visualization work. We have a small visualization team at climate.gov as well as at the climate program office. But a lot of what we do is we try to figure out ways, we give links to all the data that's available that we can find across the climate enterprise, pretty much across all of NOAA. And we have ways of doing that. You can go to climate.gov and do it. I think I can probably share my screen. Can I do that? I think I can. Let's see. I don't know. Anyway, well, I'll put some links in the window, because one thing I wanted to share with you all, by the way, those animations that we just saw were crazy. I've never seen anything like that before. 2 thumbs up. That was amazing. The tornado one was crazy. That was so
I know. We should be able to see you to see you share your screen. So we can take a moment to make sure that that's going to work.
Sure. Let's try that.
Maybe a button on the top there.
Okay.
And yes, we are so excited to see what you're about to show us. Oh, and folks are sharing more awesome work in the chat in the meantime.
Cool.
So we have so many resources. Excellent. All right, it's there. Take it away.
It's there. Whoa. Yay. Okay. So yeah, climate.gov, we do cool stuff. So we have basically multiple sections. I mainly do a lot of writing in the news and features section of climate.gov. The mission of climate.gov is specifically for climate education. So coming up and thinking about new ways of visualizing is always great. And oftentimes, we get stuck in terms of we have all of this data, but coming up with new and innovative ways of displaying it is oftentimes the limit for a lot of times of what we have to produce. We just don't have a big enough team to do lots of visuals. So that often is kind of like the roadblock for oftentimes when we're thinking about new data. Other cool things we do, we have our own visualizations. All the data is available on the webpage. Just go to climate.gov. We have a dashboard looking up new, basically your classic sort of climate change variables, but it also gets into natural climate variability and climate projections. There's also a maps and data section, which might be the one that's most interesting to all of you here. And this is basically kind of like a one-stop shop of looking for pretty much any data set you can imagine across NOAA and even across the federal government in the United States for finding data sets. So we have some of them of our own that we put on this webpage, but I could make this the whole screen. As well as basically we have data set galleries where you can basically browse all of the existing data sets. And I was going to show you a link to another webpage at NOAA, but it was currently not working. Oftentimes on Earth Day, people tend to want to come to our resources, which can sometimes hurt the website. But some examples of what we do too in terms of visualizations, we do schematics, these kind of schematical sort of that combine the basic level that combine actual data. So the images you see on the ocean are actual ocean temperatures related to these different phases of El Nino and La Nina. I should note that that's my actual area of expertise is related to El Nino and La Nina. But we also create these broader schematics looking up, basically taking existing data sets, smoothing them out and making schematics out of them. But we also do lots of things like small multiples. These are the wintertime temperature patterns during the strongest La Nina events. And again, you can find all of this data. This sort of data is strictly just from NOAA, and you can actually find on the maps and data section. But one thing I wanted to bring up with all of you that you guys all might find interesting too is that one thing we've been trying to do, but having a little bit of struggling with, is creating interactives. And interactives, this is just one example. We have all of this station data, which you can download from parts of NOAA's of the National Climate NCDC is what it's called. I can add the link into the chat window. And this is basically, we created this looking at the hottest day of the summer across the United States for thousands of stations across the United States. So basically, you can come here and you can click on any of those dots and you can find the temperature, the date, and the record for whatever it was, whatever you want to do. And this is one thing that we've been trying to do a little bit more of, but been a little bit hamstrung by just, there's so much we have to do in our given day that's difficult to do. But this is the sort of thing that I can tell you from a social media perspective, as well as looking at our Google Analytics of our web pages, is something that's incredibly popular. Are these interactive, which lets people basically take a global picture or a national picture and really make it local. So the color of the dots is really telling the national picture, because that's basically skewed. That's a color scheme skewed to what the actual temperatures are. But now it actually lets people be like, oh, I wonder what it is where I live. And we found that we get a lot more interactive and engagement when we have these interactives. And that's one thing that we've been working a lot on. But one other thing I want to share with you guys now, but now I'm kind of super excited to share with you based upon that tornado image to see what you guys come up with, is that we have these urban heat island maps. So for the last 4 years, across the country, across the United States, we've been funding groups and communities and city and NGOs in certain cities across the country. They have to apply based upon their collaborative group that they're doing to see whether they can actually map the urban heat island. And we've been funding people to go on these transects through cities in cars and in bikes to monitor and measure their urban heat island on roughly the hottest day of the summer for the last 4 years for about 25 different cities across the United States. So what we've gotten is we've gotten these really high resolution images of the temperature across major cities across the United States on a really hot day. And this has been done 3 times during the day. It's been done in the morning and the afternoon for peak heat, and then in the evening. So basically the morning is the coolest, the afternoon is the hottest, and the evening is when things are supposed to start cooling down. But because of all of the infrastructure in cities that retain heat, it basically can make the heat last longer, and also the hottest part of the day can actually be hotter. That's basically this idea of the urban heat island. And so now we have all of these really, really high resolution maps. This is what it looks like for Washington, D.C. If you take a look at the blue part on top of the screen, there's a 13-degree difference between that blue and that red over the span of about 2 miles. In Washington, D.C. I believe it went from over 100 to like the upper 80s. That's basically showing what is Rock Creek Park. It's a very beautiful area with hiking trails and lots of trees, to an area which is pretty much just roads and buildings with not many city parks in that area. One interesting thing that's been shown by these studies, and this is actually one of the people who've been leading this group, is that they've looked at urban heat islands across the entire country, and they've mapped it onto historic racist policies like redlining, which is basically when banks refuse to fund or give money to people to buy homes in certain areas because they were deemed not important enough or not worthy, whatever you want to call it. And basically we can show in a lot of cities across the United States, the hottest parts of the city tend to be areas that were disinvested due to racist policies back in the middle of the 20th century. And that basically means that the heat vulnerability issues tend to fall mainly on communities of color and poor communities within cities. And the one thing why I bring this up is because all of this data is freely available. All of those maps. You can get the maps of the times of the data, the 3 times. You can get the maps of the transect. So basically the way it works is that you have these different people drive through different parts of the city. And then they measure their temperatures, and then based upon satellite information showing what the actual land use is, they can basically extrapolate using machine learning to basically say what the heat map would look like over the entirety of that city based upon the information getting from those, from the cars or from the people, to create these things. And all of these, there's a website that's a story map, which I can share with you, and that also gives links to all of the open data for it. But this is freely available. And one thing that we've been trying to do a lot of now within this program, which is part of the Nationally Integrated Heat Health Information System, which we call NIHIS because we love acronyms and long names, is that we're trying to basically, the cool thing about these efforts is that it's collaborative, and it involves not only city officials, but it really involves community groups monitoring and measuring the heat that affects them. So they basically, it's like a big event in these cities. They have lots of publicity for it. They get really excited about it. They get this data, and now the question is, what do you do with the data? So one thing that we're trying to think about from a NOAA perspective, a Climate Program Office perspective, is how can we facilitate decision-making or public policy based upon these sort of urban heat island maps. And a lot of that comes down to also, how can we use these maps? How can we visualize these maps? How can we use this data and combine it with other visualizations to basically spur some sort of interest? So one thing we've actually been thinking about, which may be interested in anyone here, is that we're actually starting to think that maybe we should hold hackathon-style events as it relates to these maps, where we bring everybody together. with a common question and a common goal and a common data set. And people can bring their own expertise and interest into it and kind of come up with maybe some solutions to how these things work. But I'll stop there. I think I've talked too much anyway, which is probably true. Yeah, so like that's a cool new thing. And this summer, we are mapping, good Lord, at least I think 15 different communities in 11 different states, including New York City is getting mapped, San Diego, San Francisco, Atlanta, pretty much all these small towns in Virginia. I mean, it's really it's a large map. So if people are interested in that, I'd love to talk more about it, or yeah, we can connect.
Amazing. Thank you so much for sharing all of these amazing ideas and work with us, Tom. This is so fantastic to see. And I know folks are really excited about it. In the chat, everyone is super excited by ideas of being able to collaborate and work with this data and things like hackathons, as you suggest. So I know folks will want to follow up with you. Hopefully we can collect some of these links in the notebook for the event for posterity afterwards. But is there also a good way folks can follow up with you? To connect with you after the event?
Sure, I'll just put in my email address and then folks can just email me. That's the easiest way, because I'm on my computer all day, every day. And I will say, I started as a scientist and I've moved more into communication realm. So coding has been one of those things that like, I'm always very impressed by everything that you guys with coding and all this stuff. And I was looking through all this stuff, and it makes these notebooks are so much easier. I wish I had these when I was. This is such great stuff. It's such a great collaborative effort. It's very exciting.
That is our hope. Thank you so much. And we I know folks are really excited to get their hands on this data and would love to get some of this data ported into Observable so that we can allow folks to run with it and build out and see where we can take it next. So I'm sure folks will be in touch. We'll share the resources that we can grab after the talk. And yeah, thank you so much for being here with us and sharing.
Thanks, everybody.
This. And next up, really pleased to meet Jeff. Hi, Jeff. Lovely to have you here.
Hi, nice to meet y'all. Yeah, it's been really impressive. A lot of these visualizations are really top notch. So yeah, I work with the NOAA Fisheries. I'm in the Southeast Regional Office. That's in St. Petersburg, Florida. So I'm a research fisheries biologist. Our primary goal is we manage the fish stocks. So that's in the South Atlantic and the Gulf of Mexico. So a number of commercially important and commercially and recreationally important species. So I'll go ahead and share my screen here. Let's see here. You know how to share it?
Yeah, we should have there should be a little button when you hover over the top of your video.
Okay.
And in the meanwhile, I think we have folks already sharing some resources in the chat. And yeah, how to reach out to Tom on Twitter. And Jeff, we're super excited to have you here. We'll have to get your the best way to contact you after we chat here. But we're really excited to see what you want to share with us today. If that share screen button is not showing up, then we can. Oh, there it goes.
How does that work? Okay, I figured it out. Thank goodness. So anyway, I work in the Southeast Regional Office for NOAA. So we are responsible for the fish populations, working with managers to ensure they're sustainable. So a lot of that we do statistical analysis and data requests for different management actions they have in the region. Managers use this information for providing decision making and different management function. And typically we present it through either oral or written reports. A lot of our analysis are done with certain methodology that's been kind of done over time. So as someone in my position, kind of a data scientist, I regularly work in R, SAS, SQL, and Excel. A lot of our deliverables, we usually work with the public quite a bit. The public, it just tends to be more used to, I guess, Word and PowerPoint, but these kind of notebooks you're describing are really, really interesting for us. I'll get to in a second what exactly we do. This slide here goes with just the different recreational data sources. So the bulk of my job is primarily data wrangling. Some of these data sources are publicly available, such as the MRIB data site, but some of the state data, it's typically only available upon request. So you can see a lot of these different data sources feed into our analysis. Kind of get into visualizations. Typically, R and Excel are what I prefer. Some folks in our office do use SAS. For R, I definitely prefer the ggplot2 library. The two graphs here on the bottom left visualizes a regression model, just predicting some different variables on the discarding of certain species that are managed, such as red grouper, GAG, and other grouper species in the southeast. The plot on the right shows kind of the discard probability by size for different fish species that are managed down here in the southeast. You can see a lot of the fish species are managed by minimum size limits. So if it's under a certain size limit, it would be discarded. Typically, most of our plots are just kind of typical bar plot, line plot, nothing too exciting there. This plot here I threw in is just a visualization of a Sankey diagram made in R. On the left, you have the different kind of inputs. This is representing the per capita consumption model. This is for an assignment I did for NOAA headquarters. This is to visualize how much seafood people in the U.S. are eating, domestic seafood consumption. So we have different, the top left is the domestic output, and we have imports, and we have kind of the can section on the bottom of the zone, and how those all kind of feed into in the far right and the kind of middle there in the red block, what's actually consumed in the country, which is a little under 20 pounds of seafood per person per year. Animation, so this is just something in the regional office, pretty much as far as visualizations go, it's a team of two, me and one other person. So these are made with GG Animate and R. The figure on the left just kind of gives the number of artificial reefs off of the different coasts in the Gulf of Mexico, so Florida on the far right, and following a counterclockwise, Alabama, Mississippi, and Louisiana, just kind of showing the propagation over time. And on the right, just kind of similar to the plot previously shown with the stack bar plot, just the different model variables and their influence on discarding. The previous, I think it was Maya, talked about Shiny. So I have gotten into making some Shiny apps. So the interactive, kind of reactive website is something really exciting that we're excited to use. The reason being is a lot of our analysis, we work with different constituents, so the public, either recreational fishermen or commercial fishermen or charter fishermen, and we want to look at the effects of different management actions on that would have an effect on them. So this is the Shiny Decision tool here in the link. You can kind of look at on the left, you can kind of open and close different months of the year. We also allow the user to explore different, how many fish they're allowed to keep per trip and how many fish per vessel, and then different annual catch limits or ACLs. So future needs. So definitely these interactive web interfaces, I think could be very, very beneficial for our region. Currently, working with NOAA, we don't, at least in the Southeast, we don't really have the ability to even host a Shiny server, which should deploy the apps. But luckily, we have these different management groups called fishery management councils that do have Shiny servers. So there's the apps in which I host them on. One thing, for us, cost, the government's always, one major hurdle, and then security, because a lot of our data, when it's aggregated, is typically publicly available. So, but if it's available at the real kind of finer scale, is sometimes not really available, just because it contains a PII or sensitive information. It contains specific sites where fishers are fishing or other economic information. But I'm really excited to learn more about Observable and how JavaScript could potentially help us in the future here in the Southeast. And thank you.
Amazing. Thank you so much for sharing this with us. And yes, we would love to see how the Observable community can help, port over some of this work on these data sets and help with those things like interactive web interfaces and prototyping those and making, we have the capability on Observable to embed cells from an Observable notebook anywhere on the web. So it's even possible to work with that publicly available sort of aggregated data and prototype an interactive widget in Observable and then embed it as an iframe or JavaScript snippet into whatever web page is. So hopefully helps get around some of those hosting and cost issues. And I know folks are really excited to get their hands on this type of data. We're going to try and collect data sets and other resources from this event into the event notebook after the event. And so to your question in the Q&A, Jeff, about how we can discover data sets like this on Observable. So Observable being the platform for folks to publish their own work, we don't necessarily publish our own kind of repository of data sets. However, folks through the notebooks that they publish around the platform, they share the data sets that they are either importing from other sources on the web or uploading as file attachments and things like that. So what we can do after this this amazing conversation today, we can go ahead and gather those links. Folks can even make suggestions to add new resources to the event notebook so that we can have that as kind of a jumping off point, if that would be helpful for everyone. So thank you so much for being here with us, Jeff. And how could folks follow up with you best after the event if they have more questions?
I'll put in the chat, just email, I think is probably the easiest.
Fabulous. Okay, thank you so much. And this is just amazing to see. Yeah, and I know folks would love to get in touch. So thank you so much, Jeff, and welcome Gabe, who is our next speaker. Oh, and Gabe's coworker in the background here.
That's the important one. That's Jasper back there.
Jasper. All right. So Gabe, thank you so much for being here with us today. We are really excited to hear about you and what you work on. If you want to share your screen, we would love to see what you're working on and would love to hear a little bit more about you and what you do.
Great. Well, thanks for having me down here in Charleston, South Carolina. A little cooler than usual today. So I am a contractor for the NOAA Office for Coastal Management. So as the name implies, we do pretty much everything coastal. So kind of the big thing for people to know is we have a site called the NOAA Digital Coast. I'll put a link to that in the chat. It's really cool in that it's hosted by NOAA, but it's a partnership between different federal agencies, state agencies, as well as non-governmental agencies like the Nature Conservancy, Urban Land Institute, and a whole bunch of others. And we have data ranging from just imagery to elevation data, LiDAR, as well as digital elevation models that have been built, economic and demographic data looking at what jobs depend on marine resources, who are the people that are at risk from coastal hazards, land cover change over time. So we just have a lot of data and we spend a lot of time making the data ready for those to be able to access it, variety of different manners. But to the visualization side, I'll show a few ways that kind of highlight some of the data that we have to give an idea of how people are using this. But the idea is our role is to provide information, tools, services to people that work and make decisions in coastal areas. So to that, we have spent a lot of time. We're lucky. We've got a bunch of data folks. We've got a whole bunch of full stack developers, but there's still always room to play and room to learn. So I'll just kind of jump into one of the kind of biggest tools that people know from us. It's called the Coastal Sea Level Rise Viewer. And you can go to anywhere in the US and you can basically just saying, what happens when I put water on top of this? So this is highlighting a lot of the elevation data, but also getting to show how you can kind of put together different things to make it pop for people. So this is actually our office. We're right on, we're in a very coastal area, low-lying coastal area, as you can see. So as we start adding water, you can see the water goes up in the graphic. This is a bit of an Easter egg. We have a few fun things that pop up here. So some of our staff start getting flooded, and at 4 feet, a sea otter appears. That's typically when they show up, 4 feet of sea level. And then we start getting worried at 6 feet, we start seeing a shark come up. So this is an Easter egg. We have these types of visualizations everywhere. They're a little bit more serious, but with our staff, we wanted to make sure, we kind of showed that, we can still have fun with our data. Just the idea being, if you're going to make a decision in coastal area, you might want to look at what are the areas that are most likely to get wet. And ways that, we could see, the community using this information is, saying, all right, what are the areas where you want to make the decisions on? For us, we start at mean high water. For a lot of people in Maine, for example, their policy is made off of astronomical high tides. So they can take this information, and if they have someone, working with like an observable notebook or something like that, we could work with them to kind of start, rather than at mean high water, start at an astronomical high tide and work from there. So there are lots of ways to take these information and kind of play around with them. Kind of in a similar vein, we have the Coastal Flood Exposure Mapper. So this is looking at a whole bunch of, rather than just sea level rise, a whole bunch of different hazards: high tide flooding, FEMA flood zones, tsunami, storm surge, as well as sea level rise. And this is where we start really mashing it up with different types of information. So we've got population density, poverty, elderly, some employment information, so on and so forth. So just a quick example of Hurricane Sandy several years ago came through and hit this area as a Category 3. So I turned on storm surge, and I've got it as a Category 3 down here. And you can change that, and you can see the areas that get inundated change. The other thing, I've turned on poverty here, and I can take the transparency down, so you can start seeing there are several areas that were hit that have a high proportion of poverty in that community. So again, we're putting a lot of information out for people to use to say, okay, these are areas that are likely to be hardest hit. What resources can we have in place? We're doing a hazard mitigation plan. So we're not making those decisions, but we're trying to provide the information for people to make those decisions. And we know not everyone has people that can, build all this type of data and do the visualization. So we try to make it as simple and easy as possible. Another one is Coastal Land Cover Atlas. And so this looks at land cover change over time, depending on where you are. We've got data for the US as well as US territories. In the continental US, we have data from 1996 to 2016. And then in the Great Lakes, we've actually got some data going back to 1970. Again, showing what's changed over time. You can also look at things like what percentage of change is there in forested areas or wetlands. If you're worried about coastal erosion or coastal protection, areas are becoming more developed. They're losing some of their forested areas, which can help hold the soil, as well as, obviously can help with CO2, I'm not even going to try to say it right now. And then losing wetlands that are protections as well as habitat, so on and so forth. So lots and lots of different data. But again, the thing that I think I'm really excited about with Observable is for us, for the data folks, taking those next steps to start kind of taking the data that we have and working with our customers that may not have the capabilities to kind of do some of the kind of more localized information and work with them to say, how can we take this data and build something that's specific to your needs and what you want to do. One last one, just to show, we also have economic information. So these are jobs that depend on marine resources. So this is less map, more kind of tabular information, just kind of showing that there are a lot of people that depend on these marine resources, and there are different ways to count them. When we look at things like living resources, which includes commercial fisheries, we've got both employed and self-employed. A lot of times commercial fishermen are self-employed and they get left out of those counts. depending on who's looking at the information. So, kind of highlighting that, you really need to pull together lots of different data sets to make those informed decisions. So with that, I'll kind of finish up with what I was going to talk about.
Fantastic. Thank you so much for sharing all of this with us. I think folks are really impressed at like all of this work that is going on and all of these data sets that NOAA has been sharing with the world or with us that I think, as you said, would be amazing to see folks start to run with this data in Observable or other platforms that they're doing data viz on. So thank you so much for sharing all of this. Would folks be able to reach out to you after the event if they are interested in knowing more about some of these projects or getting their hands on some of this data?
Absolutely. I'll put my email in. I'm putting links to all of these tools as well. But yeah, I'll drop my email in, and we've got general contact info on the Digital Coast too. So lots of ways to get in touch with us.
Fantastic. Thank you so much. And I know folks are already, yes, Maya and many others of us are drooling at all of this data. So I believe Aaron is compiling all of these amazing links and resources that everyone has been sharing into a notebook that we can share after the event. So everybody has a nice jumping off point. So thank you so much, Gabe, for sharing that with us and being here with us today. We really appreciate it. And hi, Ben. Lovely to meet you. Thank you for being here with us as well.
My pleasure. It's been really interesting so far.
I agree. My mind is just like, I thought it was blown in the first 5 minutes, and it just keeps being blown more and more and more every talk. So we are really excited to meet you and hear more about you and what you work on and the work you'd like to share with us today. If you'd like to share your screen, you should be able to do that with a little button on the top of your video there. And in the meantime, thanks, Gabe, for sharing your contact info so folks and all that data and resources so folks can follow up with that. And Aaron is already working on some of these, on compiling some of these data sets together. Amazing. Yeah, so take it away, Ben, whenever you're ready.
All right, I just want to start off saying that, Gabe, I actually used that sea level rise tool to map out some of the houses that I was looking at buying at when we bought this house. So I'm down in Florida, where it is a concern and stuff like that. So that was pretty fun to see that and just kind of poke around there, see different areas of the Pinellas County where I'm at that were a little bit more risky to purchase a house. So just a little bit about myself. I work with the National Marine Fisheries Service HMS, Highly Migratory Species Management Division. So that's any of your sharks and tunas and billfish in the Atlantic side of things. So I wanted to just talk a little bit about some of the data sources that I deal with primarily, so that we get a lot of reporting that's required with anybody that's involved in some of these fisheries. And I primarily focused on the commercial side of things, so less on the recreational tournaments and just individuals that go out to fish for these type of fish. So we're talking about dealer reported landings. Anytime that somebody buys fish from a fishing vessel, they are required to have certain permits and have different things they must report. And also vessel reported trips and things like that. So anytime one of these vessels, depending on their permit, they go out, they might have a requirement to report a logbook, basically summarizing their trip, a little bit of effort and catch and things like that. And then there's also individuals, and this is how I started off in my career, was I went out on fishing boats and collected data on the fishery. So that's Fisheries Observer is the job title that I had. And that was a really interesting job. So you'd spend, up to a month or so offshore I was on shrimp boats and also on like grouper and snapper boats that went out and fish for reef fish down in the Gulf of Mexico. And so those, the primary data streams I get, unfortunately, there is a lot of issues presenting some of this data because of confidentiality. So we have the rule of 3, and this is a generalization of this rule that's part of what we're allowed to release publicly. Needs to be you can't identify anybody specifically, So it's generally aggregated to groups of 3. So if you're trying to look at landings by state and there was only 2 dealers that had purchased, you know, sharks or tunas in that state for, say, a specific year, that needs to be aggregated with other geographic regions or years so that you kind of reach that threshold of 3 before you're able to you know, share the data. So that does make it a little bit difficult for reporting on some of these things and sharing the data. But you know, so I think that there's lots of opportunities, it seems like, for Observable to kind of provide visualizations where I feel like, sorry, I was looking at the question there. I feel like that there's lots of creative ways to display the data that might be able to, you know, abide by that rule of 3 and also kind of share the data. And just to answer the question I saw, said, do the boats have cameras? Some of them do. So it's kind of a generalization to say like which ones, you know, have cameras and stuff like that. So observers, when they're on the boat, they do monitor for any kind of interactions with birds and dolphins and seals and things like that. I can go off on a long tangent about all the different, you know, bits of data we collect. So if you're curious, you can email me later and I can get back to you. I'll put my email down here. So I actually didn't prepare any data to share. However, let me share my screen. I sent Aaron a list of permits we had for vessels that carry permits that allow them to fish for highly migratory species. And I believe it was Christoph. So thank you for kind of throwing this together, you two. But this is really neat. So they put it within a notebook and basically we're able to take the CSV I sent them and it's got, you know, the vessel name, the permit, and some address information, dates, and things like that. Import the table, and then just pop it into a couple charts up here real fast. So this is, you know, pretty neat, easy thing it looked like to kind of import the charts and stuff like that. So I will say that I am, you know, also at home in R. So I think this is really cool. Maya had mentioned that you know, you could wrap the HTML and kind of use that in R for some of these D3 objects and stuff like that, which I'm really interested in learning more about that because I have very little experience with JavaScript. But yeah, so just kind of looking at different geographical areas, New Orleans, Lake Park, like just looking at Lake Park, I wasn't aware there were so many HMS permits that were in Lake Park. So I'm learning about it just from these quick little charts. But yeah, so, you know, I just kind of want to give a brief overview. I'm mostly here to just learn more about Observable and see what it's all about and stuff like that. So very impressed with everything. It's pretty neat.
Awesome. Well, thank you so much, Ben. This is really fantastic to hear and to see this live work that essentially it was a collaboration between yourself and the data that you have access to and our ambassadors, Aaron, and I believe you said Christoph. So that is amazing. Thank you so much, Christoph and Aaron. And of course, thank you, Ben, for being here with us today. Just lost Ben's video, but hopefully you folks can all get in contact with Ben and our other speakers after the event. And for now, we would love to use the rest of our time here today to have a little bit of an open discussion with the amazing scientists we've been hearing from and with our fantastic co-host, Ambassador Aaron. I'm going to start referring to you that way as a title.
Cool.
Thank you so much, Aaron. You have brought together some amazing folks and some amazing work that they are doing today. So thank you so much.
I appreciate the opportunity, and I'm always learning from everybody else. Actually, I mean, why am I an ambassador for Observable when I'm like probably one of the least coding proficient people that might use the website, and I'm also not particularly data proficient. But when I was looking through the presentations, of course, thinking about the Earth, so much of this is spatially referenced information I tried to figure out how to do that myself. And we were talking a little bit about, can we rapidly or easily prototype some of these these spatial visualizations without needing a big server, or at least just being able to consume server data. And so I was thinking about, why am I in Ambassadors? Because I shamelessly ask a million questions of the community, and people answer me. So one of my special friends on Observable, who I've never met in person, but is this guy Brian. He's given me so many tips and help, and one of them is about getting this ArcGIS server online. Now, something in my notebook has broken, which happens, and I'll figure it out and I'll share it, and I'll see if I can link in some of these environmental data sets. But there are many other people out there who are really capable and fluent in how to represent this information. So I please invite ambassadors or people on the call and others to kind of help us, point us at notebooks that you like, that can help us to kind of understand how we might process and visualize this data. And otherwise, other than plugging the community and saying, please, if you have questions you want to learn, my experiences, and Mutare just also chimed in, but he's another person who answers so many folks. But yeah, please, if you're interested to learn, don't go it alone. And even if you feel alone, maybe because we're reading the computer, there's a big community out there, and people are really helping to help us as people who might want to learn or work with data to understand how to do that with a new language and a new environment. So in case you're thinking about making that transition. Otherwise, I think we're just open for questions now. So if anybody from the ambassador side has questions, if anybody from the environmental scientist side wants to ask, just maybe chime in the chat. If there's anybody who's listening right now and you want to say something or contribute, I think we're open. We have about 15 minutes, or I've talked too long and now 12. So I kind of just hoping that other people will jump in here. Thanks.
Yeah, absolutely. And I don't know if any of our presenters are still on the call. Perhaps we can bring folks back to have a little open discussion here. I know folks have been just sharing a lot of wows and amazings, and I can't wait to get my hands on this data. So thank you so much, Aaron, for starting to compile all of this. And we are really excited to see what folks take this data and how they run with it, and what visualizations and what explorations and tools and things that the community can build on come out of events like this. We're hoping that this is a great occasion for folks who are interested, whether you've worked with this type of data or data at all before, or whether you've done kind of work in this environmental research and advocacy space, or whether you're brand new to the field and interested in it. We would love to see folks connect and start to play around with these things. So let's see, I think we have some questions coming in. I see we have one from Maya. So are there any specific questions or data sets you'd like any of the visualizers who are around in the community and on the call to dive into? So we'd love to hear from any of our presenters around what we're hoping that folks do with this data. What about you personally, Aaron? Is there anything that you're hoping that you would like to play with or see happen, or anything you're hoping that the community puts together?
Well, some more reflections on this call and thinking about the information that's shared. One of the things that I think about when I'm working with information, and I'm sorry that I don't really present much on it, I'm sort of obligated not to without a lot of permissions. But it's one thing to have this information. It's another thing to think about the story. And one of the things that you mentioned, Tom, a hackathon idea, that's a great example and a great thing to do when you can ask people to help you to explore and identify what these stories are. Because sometimes, you're looking at that data set, like the one that we were just shared and we're kind of paging around through. We didn't know kind of what's in that information. We started grouping it, we ordering it, and we're trying to suss out what those stories are. So it's really cool when, and maybe Tom can come back in if he didn't just jumped out already. But when we can
Yes,
make
we
these
just lost them.
partnerships and have people who know really intimately what's inside or what they're looking for, what the stories are that are trying to tell, say what that is, what the story is that you'd like to hear, and invite people who might just know how to visualize to help you to find and express that.
Hi again, Tom.
You're
Hi,
on the
yeah.
spot.
So yeah, so I missed. So it went to the original screen, and there was a delay, so I missed like the last couple of sentences of what you said. Like, yeah, so like, I think in general, I think I understood. If not, you could say, Tom, you're wrong. This is what I'm talking about. But like, yeah, that's the key thing for a lot of what those urban heat island maps are, is that, you know, they're great and they, in and of themselves, data doesn't do anything, right? It's what people are able to do with that data, and it's be able to tell the story. So oftentimes that we find when we, at Climate Program Up, we do a lot of stuff where we have data sets, but we're always really working in the realm of like taking the data and actually making it understandable, or at least creating a conversation about what can actually be done based upon the data. Because oftentimes what ends up happening is that you give a data set to somebody who's not an expert in it, and they're like, I don't know what this is. And that's valid. Like, you showed me data sets on a whole bunch of things, I'd be like, it looks cool, I don't know what that means. So the idea is oftentimes what the issue is like, it's just creating opportunities for people to work together across the line of things, which is one of these ideas of, you know, get these hackathons, because at least when it comes to urban heat, it affects people on such a fundamental level, on the community level, and it's very rare that you're able to get these sort of citizen science sort of events where you actually get people interested in it at a fundamental level in their own communities. And it's such a great opportunity to basically do something where it's not like a top down, it's a bottom up. And the cool thing with the urban heat island maps is that you really can take other data sets that have nothing necessarily that you would think have to do with, let's say, climate or atmospheric stuff or weather, and you could put that all on there. It's basically just geographic information. So you can relate emergency room visits by parts of your city. You can put in any sort of data that you have on a city-based level that you may already be using in economic terms, economic data, and you're able to put this onto this sort of map and basically get this interesting idea. So like, yeah, it's something we're exploring to do with these sort of like create these sort of community events through the cities and the community groups, and we're hoping to hopefully able to pull off. COVID kind of threw a whole big wrench in the plan, as I'm sure that threw a big wrench in lots of people's plans. But it's an interesting aspect of it. We're pretty excited about what's the interest that we've gotten based upon these maps has been crazy so far. So it's been I think it's a burgeoning area of interest for lots of people. So we're hoping to kind of keep going with that.
Fantastic. Yeah. And I know folks are chiming in from the chat of things of there are already ideas generating of how we can take some of this work and maybe extend it to different geographic areas. If we can find comparable data, that's one really awesome thing in Observable, is that we can fork each other's notebooks and replace whatever we want, including the data underlying it. So we could take the same visualization if we can find comparable data for a different region, a different city, a different country in cases, we can kind of plug that in pretty quickly and easily. And likewise, as you're saying, amazing to see how folks could take other geospatial data sets and see what emerges from, you know, comparing that data to the data that you've been collecting. So definitely the sort of thing we hope to see folks do on the Observable platform with the resources that have been shared. Well, whether it's Observable or an R or what have you, we hope that folks can put their heads together and really see what all we can find out from this amazing data. Because as you say, the data by itself doesn't necessarily tell us anything. It's all about the communication and the community making sense of that data, right? So amazing points. And welcome back, Gabe. Hi. Yeah, I would love to also hear what you're thinking or what you're hoping, you know, comes out of sharing some of this data, or perhaps you're also thinking about things like hackathons.
Yeah, and I'm really glad Aaron brought up the whole kind of storytelling side of this, because that's something I think we have learned through the years, where, right, you know, it used to be, yeah, we'll just throw data at people and they'll figure it out, but, you know, really there are people that want to take it and run, which is awesome and amazing. And people do these incredible mashups and, pulling together, and making inferences that you never would have thought of. And that's amazing. But there's still a lot of people that, the data is just a part of it. And I'll use an example from up in Maine. I work with our economics team in our office primarily, and we do work with communities to help them estimate their local marine economy. Where are those jobs that they depend on? And a lot of these communities are seeing a lot of pressures from kind of redevelopment of working waterfronts into areas more for hotels and tourism recreation type activities, and they want information to say, hey, look, we're still really important, still really viable part of this community, and we kind of keep getting pushed further away. We're living 45 minutes away. We can't afford to live in the area, and so the data is just like they want one number or one thing to go when they have public testimony to their state legislature, and so that's a really powerful thing to have, that one map or that one thing. But then there's the human side of it, which is really what is needed too, to take that information and make it so that people care about it, and that's where the visualizations through groups like Observable, making it easier and accessible to share these types of visualizations is huge. Like you said, you can fork and kind of take your copy of it and go drop in your own data and then tweak it. That's massive, because not everybody, and I think like a lot of people of my era, a lot of what I do is self-taught. And I didn't learn Python until I was well into my professional career, and being able to grab what somebody else did is huge, and then break it until it works. So the ability to share code like that is amazing, and just take that information and what Climate Office has, take that and overlay it with things like the land cover change. There's all sorts of fun interactions that can be had across a lot of different disciplines. So that's what I'm hoping for.
I'm sorry, I was trying to type responses to questions while you're also talking about that. But yes, the linkages also to policy are pretty important ones, and I think that's what I think is the most powerful aspect of visualization. One of the reasons why I'm really trying to learn more myself, and while I'm happy about these events where we can start linking people who are better on each side of the equation of maybe thinking and generating information and then expressing and visualizing it, because these are different skill sets. But ultimately, I also think about these policy implications, because there are real challenges that we're facing about climate change, about understanding weather patterns, and about how to try to make a statement to somebody who's looking to make change and looking to make a difference, but doesn't know where to get started. And you've got to prioritize and compete against interests. And so it's one way to, I think, help us to raise the power for me of social and environmental issues, because we can say, look, there are very clear ways and very easy to validate and easy to share ways of interpreting the information around us, so that we can understand the implications of choices that are being made, like whether it's a subsidy for a particular agricultural product, or you're trying to make a fisheries intervention where you want to control populations, or maybe protect endangered species. All of this, I find, is the value of a community like Observable. And the question that I was responding to with Tyson, I mean, it was trying to say there's a yes and no answer to, is there a place that you can just go and with limited knowledge of JavaScript, post your idea for something that you want to learn and have people help? And I think that the talk.observable, the community forum part of this platform, does offer that opportunity. It's not like, okay, you just put up what you want and somebody's maybe going to just do it for you, right? Like my experience is more that you have to be willing to learn yourself, whatever you're trying to achieve. But I have the most viewed question of all times on the Talk forum. And that question is, how do you load a JSON file into this notebook so that you can actually work with it, right? Like 22,000 people have seen this question for whatever reason. And it's all because I didn't know what I was doing. But I wanted to kind of to figure it out. I wanted to learn, how am I going to access information? How can I dig into it? And people guided me through that very kindly. So I guess on that, it's kind of my concluding remark is thank you and welcome. And if you're looking to explore and do more things with data together, like, let's keep this conversation open. And I'm going to try to help to do that from the notebook perspective. I wish that everybody on this call reaches out to one another bilaterally or in a group, and we can just kind of help to keep things rolling and to think about, what do we want to do, what do we want to accomplish, and how can we help one another. So thanks, everyone.
Love it. Thank you all so much. Thank you, Aaron, for bringing all these amazing speakers together. Thank you, all of our amazing speakers, all of our ambassadors who are with us today. This has just been such a fantastic conversation. Thank you so much. And we're hoping the conversation can keep going on the forum and in these notebooks. So we have comments that you can leave on each other's notebooks if you are interested or have questions about some of the notebooks that have been shared. And we have the forum at talk.observablehq.com, where you can, as Aaron is saying, ask questions that many other people have, because everyone always has those questions, and where we can learn from each other. So thank you so much, everyone.
Yep.
And thank you, Wayne, for running this show today.
Welcome. It's been an awesome experience, awesome event. Is again, +1 to what Anjana said, +1 to what Aaron said. Just want to thank you all to our speakers. Thank you everyone in the audience for attending. Thanks to the Observable team for the support. Thanks Anjana for being a great host. And this is a community-led event, and appreciate you all. So thanks for everyone, and feel free to stay to hang out in the chat if you want to a little bit longer, and hope to see you in the notebook.
Thanks so much, everybody.
Thank you.
Lovely meeting you all.
And please feel free also to reach out and find me. Most people have my email, otherwise I'm on the forum. So thank you.